This is the last video to get you ready for the 5354 quiz. The previous videos specifically focused on one topic, whether it was radicals or solving or the complex ideas. This video is kind of a combination type video where we're going to look at all the individual skills in one slide that you're going to have to be able to do in order to be successful on the quiz. So we're going to start off with some square root simplifying. We've got some multiplying, some adding, and foiling. We're going to get a solving one, and then we're going to talk just briefly about complex numbers because the majority of problems will be done on your calculator. So starting with number 1, you're asked to take the square root of -8 times the square root of 10. What we talked about in class is when values are under square roots and being multiplied, you can multiply them together and keep the square root. So first thing I'm going to do here is I'm going to multiply -8 by 10 and get -80 and write it as the square root of -80. Next thing I want to do is I want to look at just the 80 and think about the perfect square factor that is the largest perfect square factor that goes into 80. Again, we talked about the importance of having your perfect squares listed at the top of your quiz so you can refer to them. This one, the largest perfect square factor is 16. It is 16 times 5. We talked in class that you want to take the square root of the one that is perfect and you want to leave the other one stuck underneath the radical. Now we do have one other issue here that we need to deal with. We have a negative under the radical. We talked in class if you have a negative under a radical, what you do is put an I in front of your square root, showing that you understand that the square root of a negative number is considered I, or an imaginary piece. So my answer for this one would be 4, because that's the square root of 16. I, because there was a negative under the radical, and then the 5 is permanently stuck under the square root, and that one's finished. The next one, when you go to add square roots, you can only add square roots that are alike, and what that means is the number under the radical has to be exactly the same. These two radicals are not alike. So what I have to do is I have to do some work to get them to be alike. If you look at the 5, there is no perfect square factor of 5. It's a prime number. So what I'm going to do instead is I'm going to look at the 80 and do the same thing. Now the nice thing is you just dealt with 80 on the previous problem, so you should already know that 80 is 16 times 5. So if I write down the first piece, the 2 radical 5, what I'm going to have next is I'm going to take the square root of 16, which is 4, multiply it by the 3 that's already there. So I'm going to have 3 that's there, 4 that gets brought out, so I have a 12 now in front of the radical, and I have a 5 that is again stuck inside the radical. Now you'll notice the radicals are alike. They are both in terms of radical 5. So I add them together just like I add like terms. 2 radical 5 plus 12 radical 5 is 14 radical 5. And that problem's done. The last skill that you'll need to be able to do with square roots, you should be able to FOIL them. We showed some foiling with and without variables. I think the last video I did one without variables, so this one I did one with variables. We are going to FOIL it exactly the way we did with other binomials. So my first is going to be multiply these together. When I multiply things together, I multiply things that are outside square roots together, and I multiply things that are inside square roots together. So I have a 2x times an x, that gives me 2x squared. And then I have the square root of 3 times the square root of 3, and we also talked in class that when you multiply square roots that are identical together, you get the value that is inside, because you end up with the square root of 9, which again is just 3. So I have times 3. I'll fix that and clean that up a little bit in a second. Now I'm going to do my outer, the O in FOIL. 2x times 5 is 10x, and then we still have a radical 3. Didn't leave myself enough space for the x. So I have 10x radical 3. Then I'm going to do my inner, which is going to give me a negative 7x radical 3. And finally, I'm going to do my last. Negative 7 times 5 is negative 35. A couple things I'm going to do here. First of all, I'm going to clean that up a little bit. We can multiply the 2 and 3 together, so we get 6x squared. The other thing that I'm going to do is I realize that these are like radicals. They are both in terms of the square root of 3. So I have 10x squared root of 3 minus 7x squared root of 3, which gives me 3x squared root of 3. And then the minus 35. So I end up getting 3 terms to my answer. So those are all the skills that you need to know how to do in order to take this quiz. You should be able to work with basic square roots. For example, if I just said what's the square root of 125 or something like that where you have to go through that perfect square list, you should be able to multiply them, add them, and FOIL them. For the solving, we had a lot of different solving. We have a previous video that reviews a lot. I just want to do one more with you. We want to isolate what is being squared. Oh, I have a typo in here. This should be a 2. It should be 2x minus 3 squared minus 5 equals 27. So my first step is going to be to add 5 to both sides. So I get 2 times x minus 3 squared equals 32. Divide both sides by 2. Again, the goal is to isolate what is being squared. Cancel the 2's here, so I get x minus 3 squared equals 16. Take the square root of both sides. And here's where you need to keep in mind, when you take the square root of both sides, you get two answers. You get a positive answer and a negative answer. So I get plus or minus 4. 16 is a perfect square. You don't have to find a perfect square factor because it already is perfect. This is a little different type case here. Whenever you end up getting no more radicals in your problem, you actually get all whole numbers. We're going to set this up slightly different. We're going to set this up as two separate equations. Either x minus 3 equals 4, either it was the positive case, or x minus 3 equals negative 4. Since you have those two branches, you can think of two ways to find your solution. Neither of them have radicals, so we actually do a little bit different, a little bit more work with this problem. So we add 3. My two answers are either 7. If I add 3 over here, I get negative 1. So there are my answers. If you wanted to see if your answers make sense, you can take the original, those x values, put it into the original equation, and make sure that they make the equation true. The last problem I put up here really isn't any work associated with it. I just want to make sure you remember the language and the terminology we used in class. Complex conjugate. If you think about a complex number means it has a real part, the part that doesn't have the I, and the imaginary part, the part that does. The complex conjugate is the exact same complex number, except for the sign between the real and the imaginary part is opposite. So my complex conjugate for this one will be negative 5 minus 7i. What's special about complex conjugates is if you multiplied them together, so if I took the negative 5 plus 7i and I multiplied it by negative 5 minus 7i, and you would do that on your calculator, you will always get a real number. There will be no i's left. So if you actually wanted to practice your multiplication, you could pull out your calculator, make sure you're in imaginary mode, and multiply them together, and your answer will not be imaginary. It will be a purely real number. With this review video combined with the other ones, you should be ready for the quiz.